Imagine you are ordering food online. You place an order. Now imagine the restaurant says, please stay on the phone until we cook your food. So you wait 5 minutes, 10 minutes, 20 minutes, 30 minutes doing absolutely nothing. Sounds ridiculous, right? Now imagine a different scenario. You place the order. The restaurant says your order is confirmed. We will notify you when it's ready. You hang up. Continue your work and later receive a notification. Much better. Interestingly, these two situations represent one of the most important concepts in system design. The first is called synchronous communication. The second is called asynchronous communication. And understanding the difference between them is critical because almost every modern application from Amazon to Netflix to WhatsApp uses both. Now let's try to understand what was the problem before. Let's imagine we are building Amazon. A user clicks buy now. Seems simple, but behind the scenes many services are involved. Order service, payment service, inventory service, notification service, shipping service. All these services needs to communicate with each other. The question is, how should they communicate? Should they wait for each other or should they work independently? That's where synchronous and asynchronous communication enter the picture. Now let's try to understand synchronous communication. Think about a phone call. You call your friend, you ask a question. Now what do? You wait. You cannot continue the conversation until your friend responds. That waiting behavior is exactly what synchronous communication looks like. One service sends a request, then waits until another service responds. Only then can it continue. Synchronous architecture looks like this. At the top, we have the order service. Imagine the customer clicks the buy now button. The order service receives the request. Before creating the order, it needs to verify whether the payment was successful. So it sends a request to a payment service. Notice the arrow connecting the two services. This represents a direct request. Now the important thing happens here. The order service stops and waits. It cannot continue processing. It cannot confirm the order. It cannot move to the next step. Everything is paused until the payment service responds. If the payment succeeds, then the response comes back and the order service continues. This is synchronous communication. Request, wait, response, continue. Now why synchronous communication feels natural? Most developers start with synchronous communication because it feels intuitive. It's similar to how we naturally communicate. Ask question, get answer, move on. And that's why HTTP's APIs are usually synchronous. For many applications, this simplicity is incredibly valuable. The real world example you can consider of login system. Imagine logging into Netflix. You enter your username password. The application sends a request to authentication service. Should Netflix immediately let you in without checking your credentials? Of course not. The system must verify the credential first. The browser waits. The authentication service validates the credential, then responds. Only then can the user continue. This is a perfect example of synchronous communication and it's exactly the right choice because the user needs an immediate answer. Now the hidden problem of synchronous communication is, now let's imagine our application becomes popular, traffic increases, thousands of users become millions of users. Suddenly the payment service becomes slow. Instead of responding in 100 milliseconds, it now takes 5 seconds. What happens? The order service waits 5 seconds, the user waits 5 seconds, the entire application feels slow. Now imagine the payment service crashed completely. The order service cannot get response. Order failed. Customers become frustrated. One service has become dependent on another, and this is the biggest weakness of synchronous communication. And there is a cascading failure that makes things even worse. Let's follow the request to understand this. The order service talk to a payment service. The payment service talk to an inventory service. The inventory service talk to shipping service. Now imagine the shipping service becomes slow. The inventory service starts waiting. Because inventory is waiting, payment starts waiting. Because payment is waiting, order service starts waiting. And because order service is waiting, the user starts waiting. A problem is one service spread across the entire system. Like a rows of dominoes falling one after another. This is called cascading failure in system design. And large scale systems try very hard to avoid this situation. So engineers needed a better solution, right? So at some point, engineers started asking a different question. Why should service wait? What if they could continue working independently? What if one service could hand off a work and immediately move on? And that's where asynchronous communication enters the story. Now let's try to understand asynchronous communication a little bit. Think about sending a text message. You send the message. Do you sit staring at your phone waiting for reply? No, right? You continue your life. You attend meetings. You watch YouTube. You eat lunch. And eventually the reply arrives. That's asynchronous communication. You don't wait. You continue. The response happens later. The sample asynchronous architecture will look like this. A user places an order. The request first reaches the order service. The order service processes the orders and confirms it. That's the order confirm step shown in the middle of the diagram. Now notice something important. The order service does not directly call the email service. It does not directly call the analytics service. Instead, it places a message into a message queue. Think of message queue as a mailbox. The order service drops a message into a mailbox and immediately continues. Its work is finished. The user instantly sees order successful. Now the message queue takes responsibility. One copy of message goes to an email service. The email service sends the confirmation email. Another copy goes to analytics service. The analytics service records business metrics. Notice what happened. The order service didn't wait. The user didn't wait. And both background services can work independently. This is asynchronous communication. Now why queues are so powerful? The queues act like a buffer between services. Imagine a flash sale. 1 million orders arrive. The email service can only process 10,000 emails per second. Without a queue, the email service would become overwhelmed. With a queue, messages simply accumulate. The email service processes them gradually. The system remains stable. This ability to absorb traffic spikes is one of the biggest advantages of asynchronous communication. Few real-world examples includes Amazon. When you place an order on Amazon, many things happen. An email is sent, an SMS may be sent, analytics are updated, recommendations are recalculated, fraud system may be updated. Should the customer wait for all these operations? Of course not. Amazon processes the critical path first. Everything else is pushed to queues and handled asynchronously. That's why the user receives an immediate response. Another example is of YouTube upload. Imagine uploading a video to YouTube. The upload completes, but YouTube still needs to generate thumbnails, create 480p, 720p, 1080p versions, scan for copyright violation, extract metadata. This can take several minutes. Instead of making you wait, YouTube accepts the upload and process everything asynchronously in the background. Another similar example is of WhatsApp. When you send a WhatsApp message, the message is stored, notifications are generated, analytics are recorded, delivery status is tracked, read receipts are updated. Many of these activities happens asynchronously. Otherwise, every message would feel very slow. Now, when you should use synchronous communication. So use synchronous communication when the caller needs an immediate answer. Example, login, checking account balance, product search, payment verification, authentication. These are the real use cases where you must use synchronous communication. The user cannot proceed without a response in this case. Now when to use asynchronous communication? Use asynchronous communication when work can happen later. Example, sending emails, sending notifications, video processing, analytics, report generation, recommendation updates. The user doesn't need immediate completion for all these tasks. So in this case, you should use asynchronous communication. Now let's try to understand some of the trade-offs of each type of communication. So trade-offs for synchronous communication is it's simple, easy to understand, easy to debug, immediate response, strong consistency. These are the advantages, but disadvantages are it's tight coupling, higher latency, poor fault tolerance, cascading failures, and lower scalability. For asynchronous communication, the advantages are it's a highly scalable, better fault tolerance, handles traffic spikes, services remain independent, better resilience, and disadvantages are more complex architecture, harder debugging, eventual consistency, delayed processing, requires queues and messaging infrastructure. By this time, now you can answer these frequently asked interview questions. What is the difference between synchronous and asynchronous communication? The answer is simple. In synchronous communication, the caller waits for a response. In asynchronous communication, the caller continues without waiting. Second question is, why do microservices prefer asynchronous communication? Answer is because it reduces coupling, improves scalability, and prevents cascading failures. Next question can be, can a system use both? Absolutely. Most production systems use both. User-facing operations are usually synchronous, background work is usually asynchronous. What technologies are commonly used for asynchronous communication? We have seen, right, the queues. So different types of queues. RabbitMQ, Apache Kafka, Amazon SQS, Google PubSub, all these are the technologies which one can use to leverage asynchronous communication. Next question can be, why does asynchronous communication improve reliability? Because messages can remain in queue even if downstream services are temporarily unavailable. Now, common beginner mistakes which people usually do during synchronous and asynchronous communication. First mistake is thinking asynchronous communication is always better. It's not. Many operations requires immediate responses. Second mistake is ignoring debugging complexity. Tracing a synchronous request is easy. Tracing an event across 10 services and multiple queues is much harder. Next mistake is forgetting that queues themselves can become bottlenecks. Every new component introduces new challenges. Now let's try to recap what all are things we covered in this session. Synchronous communication is like a phone call. You ask, you wait, you get an answer. Asynchronous communication is like a text message. You send, you continue working, the response comes later. Modern system uses both. Synchronous communication is ideal when immediate answers are required. Asynchronous communication is ideal when scalability and resilience matters more. Synchronous communication optimizes for immediate responses. Asynchronous communication optimizes for scalability and fault tolerance. And understanding when to use each one is one of the most important skills in system design.